Okay, shall we start the class?
Yes, ma'am.
Yeah. So I think I'm audible to all of you. So see, let's just revise once. So are you able to see the screen? Right.
Yes, ma'am.
So in the previous classes, we have discussed about VLSI, existence of BJT, and these things I'm not going to revise again. Existence of BJT, MOSFET, regions of operation of MOSFET, regions of operation of MOS, and what else we have discussed? PMOS, PMOS, NMOS. Okay. And we have also seen in operation of PMOS and NMOS also we have seen. And in ASIC design flow, I have explained you about each and every step starting from the specifications, RTL design, and whatnot, simulation, synthesis, and what is this coming simulation synthesis till the back end which is covering the physical design, floor planning, clock tree synthesis, routing, and all those things. Okay, this is about the ASIC design, and also I have explained you about what is that layout. Okay, in the importance of layout, and this layout information will be given GDS2, and what are the different layers which we have in the fabrication of digital circuit, and these things, all the basic things we have seen. So today we will start the for digital design. Okay. So in this basics, still if you want to know anything, you just let me know. In between, I will be covering these things. Okay. So now I will ask you some questions like before starting today, we will be starting the digital systems. Okay. Digital system design. Okay. So digital system design. See here, what is the need of this digital circuits? What is the need of this digital systems or digital circuits? Uh, and see what are the different types of systems we have. We all know analog systems are there and digital systems are there. Okay. So what is the difference between analog system and a digital system? Can anyone tell? You can ping or you can unmute. Anything is up to you. What is the difference between analog system and a digital system? System is the one which is generating the output for a given input. Okay, this system may be anything. Okay, it may be a control system, or it may be a computer system, or it may be anything. It may be a digital watch, or it may be a digital clock, or it may be a plant. Okay, so it may be a machine. Okay, so anything. System may be anything. Okay, which is generating output for a given set of inputs, that is a system. So we classified into analog and digital system. What is the difference between what is analog system and what is digital system? Anyone?
Digital system means to understand the computer understandable language, madam. Digital language.
Okay, computer understandable.
That means zeros and ones, binary.
Represented with zeros, ones. Okay, anything else?
Next, analog వచ్చేసరికి that is continuous electrical signals pass చేసుకుంటాం. యూజ్ చేస్తాం అందులో.
Analog means continuous electrical signals. Okay, digital means two levels, on, off, లేదంటే true, false. Yes. Anything else? So as you told, continuous analog circuits or analog systems. So voltages and currents vary continuously with continuously at different instances. Okay, so voltages or currents vary continuously. So let us suppose if we talk in contrast to signals, ఇప్పుడు ఒక అనలాగ్ సిగ్నల్ అంటే ఎలా డిఫైన్ చేస్తాం? అనలాగ్ సిగ్నల్ is a continuous signal. So we can define the signal at any instant, at each and every instant of time. At this particular time, so I can define this signal. Okay, at each and every instant of time. Let us suppose this this is time. At each and every instant of time, I can define the signal. Okay, so here see analog. This is the analog signal, and coming to the digital signal, it will be like what these are discrete. Okay, so we will be having samples only. Okay, we will be having samples only. So discrete, this is discrete. From discrete only we will be obtaining digital. Okay, so discrete means nothing but samples. So for this discrete signal, so at all instance of time, ప్రతి time instant దగ్గర చూడండి, ఈ time instant, at this particular time instant, let us suppose t is equal to 1 దగ్గర I can define the signal. Okay, but see at this particular time instant, there is no sample, and also at this particular time instant there is no sample. Okay, so I cannot, at each and every time instant I cannot define the signal. Okay, that is called as discrete signal. Okay, so discrete signals are digitized. Okay, I will set a threshold value. So above the threshold I am considering it as ones, and below the threshold I am considering it zeros. Okay, I can convert the discrete samples into digital into a digital signal. So see here, so why this analog signal and why to convert into discrete values, again why I need to convert into digital signal, idantha enduku ee whole anta cheppandi.
Communication కోసం.
Hmm?
Data communication.
డేటా కమ్యూనికేషన్ కోసం ఇదంతా ఎందుకు అవసరము? డేటా కమ్యూనికేషన్ అని అంటున్నారు. కమ్యూనికేషన్ కోసం డైరెక్ట్ గా ఇప్పుడు అనలాగ్ సిగ్నల్ నే నేను త్రూ మీడియా ఐ కెన్ ట్రాన్స్మిట్, రైట్? ట్రాన్స్మిట్ చేయొచ్చు కదా.
అనలాగ్ సిగ్నల్ నాయిస్ కి ఎక్కువ ఎఫెక్ట్ అవుతుందని డిజిటల్ వాడుతుంది.
వెరీ గుడ్. ఓకే, so these analog signals are more they are easily effective with noise. Okay, నాయిస్ తో పాటు మీరు సిగ్నల్ ట్రాన్స్మిట్ చేస్తే అవుట్పుట్ ఏమవుతుంది? whenever you are transmitting the signal, ఇప్పుడు నాయిస్ యాడ్ అవుతుంది అనలాగ్ సిగ్నల్ కి. యాడ్ అయిన నాయిస్ తోటి మీరు ట్రాన్స్మిట్ చేసినప్పుడు ఏమవుతుంది?
రెండు మిక్స్ అయ్యి నాయిస్ ఎక్కువ ఎఫెక్ట్ అవుతుంది. నాయిస్ ఎక్కువ ఇంక్రీజ్ అవ్వడం
రిసీవర్ దగ్గర అన్వాంటెడ్ అనేది అవుతుంది.
ఆ రిసీవర్ దగ్గర అన్వాంటెడ్ సిగ్నల్ వస్తుంది. See that advantage is nothing but like we are expecting something. Let us suppose ఇప్పుడు నేను ఏం చేశాను అని అంటే, సో ఎక్స్ ఆఫ్ టీ అనే దాన్ని నేను ట్రాన్స్మిట్ చేశాను అలానే త్రూ మీడియా ఏదైనా కావచ్చు. ఇట్ మే బి ఎయిర్ ఆర్ ఇట్ మే బి ఎనీ వైర్ ట్రాన్స్మిషన్ కేబుల్, ఎనీథింగ్. ఈ మీడియా తోటి నేను అనలాగ్ సిగ్నల్ ని ఇక్కడ ట్రాన్స్మిట్ చేసినప్పుడు ఇట్ విల్ నాట్ బి ఎక్స్ ఆఫ్ టీ, ఇట్ ఈస్ ఎక్స్ క్యాప్ ఆఫ్ టీ. ఎందుకనంటే దెర్ విల్ బి వేరియేషన్. ఈ వేరియేషన్ కి ఎక్స్ క్యాప్ ఆఫ్ టీ. ఓకే, ఎక్స్ క్యాప్ ఆఫ్ టీ అంటే ఏంటిది? ఎక్స్ ఆఫ్ టీకి ఏమవుతుంది అని అంటే సమ్ నాయిస్ యాడ్ అవుతుంది, విచ్ ఇస్ నథింగ్ బట్ ఎన్ ఆఫ్ టీ. ఓకే, సో ఈ నాయిస్ యాడ్ అవుతుంది. సో వాట్ ఎవర్ వీఆర్ ఎక్స్పెక్టింగ్ వీఆర్ నాట్ గెట్టింగ్. సమ్ టైమ్స్ sometimes it is not possible. ఇది ఏంటిదనంటే this is the error. Sometimes it is not possible to remove this error value, okay, which is the additive noise which is added. It is difficult to remove. Okay, that's why what we are doing is, again మళ్ళీ నేను కొంచెము మీకు డెప్త్ లో వెళ్ళాలి అని అంటే ఇక్కడ మనము ఇప్పుడు చూడండి, సిగ్నల్స్ అండ్ సిస్టమ్స్ మీకు అందరికి ఐడియానే ఉంటుంది మనం చదువుకున్న సిగ్నల్స్ అండ్ సిస్టమ్ లో. సో ఫస్ట్ what we are doing is whatever the analog signal is there, whatever the analog signal x of t is there, what we are doing is sampling first. Okay, sampling tarvata again what we are doing, digitization. Okay, so this digitized image, what we are doing with digitized image, we are transmitting. Okay, we are transmitting. Okay, so transmit చేసిన తర్వాత ఇక్కడ ఏమవుతుంది మళ్ళీ again, so again what happens at receiver దగ్గర transmit చేస్తాం. receiver దగ్గర ఏమవుతుంది చెప్పండి? receiver దగ్గర reverse process. Okay, again these samples are converted into continuous signals. Okay, it digitize అయింది. digitize అయిన signal నుండి మళ్ళీ you will be obtaining the samples. మళ్ళీ digitize అయిన signal ఈ samples నుండి again you will be converting into signal. Okay, so ఇదంతా what transmission, whenever we want to transmit any signal, this is the procedure which we follow. So but here important point I want to stress is sampling is very important. Sampling తర్వాత మనం ఏదైనా transmit చేయాలంటే digitization is very important. Okay, so we are concentrating on this digitization process. So let us I will show you one PPT. Taking more time to show the PPT. Okay, I think you are able to see chapter 1 and ఒకటి కనిపిస్తుంది కదా, చూడండి. So see here. So these are all the, can you see the slide? Can you see the slide? Why study digital design on ఉంది?
Yes, ma'am. Yes, ma'am.
Yeah, you can see the slide, right? Okay, so if you see all the electronic devices are becoming digital. Okay, all these things we have discussed in the first class only. The electronic devices ante, see, sound recorders, cameras, cell phones, medical devices, video games, personal digital assistants. Okay, so these are all the digital devices only. They are running with DC power. Okay, so if a laptop is also the digital device only. Okay, so see, whatever we are seeing in today's world, everything is digital only. Okay, now you see the clear picture of analog versus digital. So analog is having infinite possible values. Okay, infinite possible values anante, if you take a signal, if you take a signal, so at each and every instance of time you can define the signal. Okay, that means ఏ టైం దగ్గర మీరు ఆ సిగ్నల్ magnitude కావాలి అని అంటే you can measure the magnitude. Okay, so sound waves, okay, sound waves, they move across the membrane, so which moves the magnet and through the microphone, so which is creating current in the nearby wire. This is sound waves are the example of analog signal. Digital signal ke chudandi, you will be having only finite possible values. 1 2 3 4 buttons unnai anukondi. If you are pressing to the possible what are the possible values here? 0 1 2 3 and 4. Okay, so if you are pressing something, you will be getting that value itself. Okay, so see here, normally digital signals ki only finite values will be there, so 1 and 0. Okay, So they are represented by they are represented as 0 and 1. Okay. So one binary digit is nothing but a bit, 0 or 1. Anything is a bit. So binary, why binary is popular is transistors. Okay. So they operate in two voltages. Even if you take PMOS or NMOS, what you will see, you will be explaining them with logic 0 and logic 1 only. And one more. Let us suppose see the difference here. This is very important. So, what is the benefit of digitization? Okay, this one I would like to stress. What is the benefit of digitization? So, why? Because analog signal, it may be audio signal or it may be any signal. Okay, so if you take the temperature also, analog signal, it may lose the quality while transmitting. Why? Because as already you said, noise is added. So these voltage levels are not saved, copied, or transmitted perfectly. Okay, they are not transmitted perfectly. So if let us suppose this is the original signal which we are seeing, okay, at original signal which we are seeing. So whenever we are transmitting this signal, so so it may lose its accuracy. Okay, it may lose its accuracy. This is that signal we have transmitted, but the received signal is, see here, what the signal is so much getting disturbed, deviating. Okay, so that's why what we have to do is we need to digitize the signal. Okay, we need, if we are digitizing the signal, so analog signal, if you are want to fix the errors in the analog signal, it is very difficult. Okay, but digitized signal, okay, if you want to fix the errors or values, if you want to what fix the errors in the digital signals, it will be very easy. Okay, so this is, we are transmitting this digital signal. Let us suppose you are transmitting this digital signal, this yeah. Okay. So this signal, when you are transmitting, what happens is, so it will be even, it will be also not what noise, it will be also affected with noise, or there will be error value in the received signal. But the thing is, you can fix up very easily. That is the benefit of the digital signal. Okay, so digitized signal is not a perfect recreation, but the sampling rate here you can see, but the sampling rate is more bits per encoding brings easier. Okay, ఇదంతా what you are doing is, even నేను వేరే దగ్గర చెప్తాను. Let's stop sharing. Okay, so that is while retrieving back, so we can retrieve back the digital signals very easily than analog signals. And sorry, other benefits are, so if we talk about digital systems, so the advantages are, they are easier to design. Okay, very easier to design. Okay, so one more advantage is, so storage is very easy, information storage is very easy. Okay, and the next one is accuracy and precision. We can maintain the accuracy. Okay, so accuracy and precision wise, these digital signals systems are beneficial. And next one is, they are more versatile. Okay, so easy to use. Okay, so here more versatile means the operation will be controlled by stored in instructions. Okay, which is called as program. Okay, So programmed very easily, versatile means versatility. Next one is less affected by noise. Okay, they are less affected by noise. Next one is easy fabric analog signals. We cannot fabricate easily on a semiconductor chips, but these are easily fabricated on IC. And next one is reliability is more. Reliability and a lifetime reliability will be more. So overall ఏంటిది అని అంటే ఇవన్నీ these are the advantages of digital systems. Why? Because storage is easy and less memory is required to store the digital data. So design will be very easy, and once zeros and some logics we are using, design will be very easy. Accuracy అని అంటే even the signal is మీకు వచ్చిన signal ఇలా receive అయినా కూడా so you can retrieve it back. So they are accurate. Okay. So కొంచెం voltage levels అటు ఇటు అయినా కూడా they are more accurate. Versatility అంటే programming will be very easy, and noise and fabrication reliability, these are all the advantages. But వీటన్నిటికంటే advantages ఏంటిది, ఇంకా ఒక గొప్ప advantage ఏంటిదంటే digital circuits consume less power. Okay, less power. All the digital circuits are battery operated only. ఇప్పుడు మీరు ల్యాప్టాప్ చూసినా, సెల్ ఫోన్ చూసినా, డిజిటల్ కెమెరా చూసినా, స్మార్ట్ వాచ్ చూసినా, సో వాట్ ఎవర్ ద డిజిటల్ సర్క్యూట్స్ ఆర్ all are sorry, all consume very less amount of power. Okay, so this is one thing. And next one is we'll quickly jump into. So what are the logic levels? You told logic levels ఏముంటాయి అని అంటే 1, 0 are the two logic levels. One అంటే see, it is 1 is representing logic high. Okay, 1 is representing high. So 0 is representing low. Okay, లేదంటే ఖచ్చితంగా true, లేదంటే false. Okay, only in two answers you should you should define any output or input, whatever in two answers only, either yes or no, true or false, high or low, 1 or 0. Okay, so these are all the advantages of digital systems. And next one is digital systems law. What are the major digital circuits that you remember? So these are the advantages. If we talk about the circuits, digital circuits lo meeku em telusu cheppandi. What are the different digital circuits? You know, logic gates, very good. Combinational circuits, very good. So here what we see is, yes, sequential circuits, good. Yes, counters, flip-flops. State machines. Prom and ROM. PLAs, PLDs, TPLDs, FPGAs, memories. Okay, starting from A to D converters, D to A converters, all these things. Okay, so let us suppose. Okay, so what are the functions? What are the functions that a digital circuit can perform? General ga use chese operations ఏంటిది? What are the operations that a digital circuit can perform? Arithmetic operations. Arithmetic operations అంటే ఏంటిది? Addition, subtraction, okay, multiplication, division. These are all the arithmetic operations. Okay, so next one, you know, functions ఏంటిది? Logical operations. Okay, logical operations ఈ రెండు కంబైన్ చేస్తే this is nothing but ALU. ఇది కాకుండా so next what percentage is actually this is division. Okay, So next one is, so what is the another function? Encoding. What do you mean by encoding? Encoding ante cheppandi. What do you mean by encoding? So the functions which are performed by the digital circuits I am writing. Decoding. Next thing is multiplexing. Okay. So multiplexing. The next one is demultiplexing. Okay. So apart from this, anything is there which are the operations which a digital circuit can perform? Comparison. Okay, comparison. Comparison. Yes, counting, code conversion. Okay. Functions. These are all the functions. Next, counting. ఎవరో చెప్పారు ఇందాక counting. Very good. Counting. Next, ఇంకేం ఆపరేషన్స్ చేయొచ్చు? డిజిటల్ సర్క్యూట్స్ ఏం చేస్తాయి? Frequency. Frequency division. Frequency division. Next one is data transmission. Data transmission. ఇలా చెప్పుకుంటూ పోతే, so a digital circuit can perform many operations. Arithmetic operations అంటే you all know. Logical operations అంటే you all know. What are the different logic gates? And, or, and, okay. So nor, and nor. తర్వాత XOR, XNOR. So not అంటే inverter. Next one is buffer. These are the different types of logical operations. In logical, using these gates, you can build big logical operations also. 3 input AND gate, 4 input. Any logic equation you can implement by using these gates, right? These are all comes under logical operations only. Encoding. What do you mean by encoding? What do you mean by encoding? So encoding ki encryption ki koncham teda undi. I will tell you. See, encoder. So you meeku telusu kada. Encoder, it will take a digital data. Okay, it will take what is that? It receives digits. Okay, like alphabets or symbols. Okay, and so it receives the digits and it converts into binary data. Okay, it converts into binary data. Okay, so 4/2 encoder. Okay, తర్వాత ఏంటి 4/2 encoder, sorry 8/3 encoder. These are all the encoders. Okay, we will be designing. You don't worry about all these things. So first thing is you need to know the concept. What is an encoder? An encoder is a digital circuit which converts the corresponding alphabet into respective binary code. Okay, into respective binary. It's not data. It's respective binary code. And what is decoding? Reverse process of encoding. Okay, so decoding is, anyone? Reverse process of encoding అంటే ఏం తీసుకుంటది, ఏమి ఇస్తుంది చెప్పండి?
డిజిటల్ కోడ్ తీసుకుంటుంది మేడం. ఐ మీన్ బైనరీ డేటా, ఆల్ఫాబెట్స్.
So it will take binary coded information and it will convert into unique output. Okay, it will convert into unique output. Okay, decoding is the reverse process of encoding. ఇక్కడ ఏంటిదంటే సో ఎన్కోడర్స్ డీకోడర్స్ మీరు ఎక్కడ యూజ్ చేస్తారు చెప్పండి జనరల్ గా? So where do we use these encoders and decoders? One second, I will share. Data security, very good. So we are talking about encode logic. It performs arithmetic. Okay, logical. Next, tarvata we are discussing about encoders and decoders, right? So encoders, they will take what is the what are the encoders will it will take alphabets, okay, alphabets or symbols and converted into what binary format. And next decoders, inverse of encoder, okay, reverse of encoder means binary data they will take and converted into their respective symbols or alphabets. Okay. So encoders, decoders తర్వాత నేను ఏం చెప్పానంటే నెక్స్ట్ మల్టీప్లెక్సర్స్. ఓకే. సో వాట్ ఈస్ ద యూజ్ ఆఫ్ మల్టీప్లెక్సర్స్? మల్టీప్లెక్సర్స్ ఇంకా డీమల్టీప్లెక్సర్స్ కొంచెం ఫాస్ట్గా వెళ్తాను. సో మల్టీప్లెక్సర్స్ అండ్ డీమల్టీప్లెక్సర్స్ వై దే ఆర్ మల్టీప్లెక్సర్స్ అంటే ఏంటిది? మెనీ స్క్రీన్ ఇస్ నాట్ విజిబుల్. You can see multiplex okay, many inputs and single output, many to one. Demultiplexers ante one to many. Okay, so if we have ఇప్పుడు చూడండి ఒక see all these wires are there. Okay, these are connected to a single bus line. Okay, all these wires are connected to a single bus line. సో ఇప్పుడు ఇక్కడ ఏ అవుట్ ఇప్పుడు ఈ ఇన్ని ఇన్పుట్స్ వస్తా ఇన్ని ఇన్పుట్స్ వస్తా ఉన్నాయి. ఓకే, విచ్ వన్ ఐ నీడ్ టు కన్సిడర్, okay, which one I need to consider as the driving force. So multiplex, depending upon the select lines of the multiplexer, any one of the input will be selected as and it is given to the driver. Okay, given to this driver or any other module. Okay, so now multiplexers and demultiplexers, they will do the reverse process of multiplexing. So multiplexers are also called as what? They are called as dating. So much of data you are receiving, out of so much of data you have to choose only one. Okay, so multiplexers are called as data selectors. Okay, they are called as data selectors. And next, what is demultiplexers? One second. Okay, these are demultiplexers. They do the inverse process of multiplexing. And coming to after demultiplexers, what I told you, code conversion, comparison. Okay, so we use the comparators are also comparisons. Okay, So if you want to, what is that? Um, so if you want, comparators are also the digital circuits. If you want to compare the existing data with the stored data, you will be using the comparators. Okay. So comparators are also the digital circuits which are used for comparison operation and comparators law. So we have magnitude comparators and also we have equality comparators which we will be discussing further. And next one is code converters. What are these code converters? Code converters ante so binary code converters. Okay. So what are these code converters? So if you want to convert binary to XS3, or if you want to convert binary to gray, or if you want to convert binary to octal, so you will be using the code converters. Code converters are also the are also part of digital system. And next thing is you need counters to count the number of cycles or to count the number of pulses. You need the counters. Okay. Next one is if you want to divide the frequency, if a counter see for frequency division also the counters are used. Okay, so one signal is there. Okay, one signal is there, so to divide the frequency of this signal, okay, you will be using the frequency, you will be using the counters uh, as frequency dividers. Next one is for data transmission also. You will be what these digital circuits are, sorry, the digital circuits are used for data transmission. These are all the functions of the digital circuits for data transmission. So data transmission is this is the main important thing. Okay, so after whatever, whichever the data is there, the data should be transferred between module to module. Okay, it may be the serial transmission or it may be the parallel transmission. So parallel data transmission means all the bits are transmitted simultaneously. In serial, bit by bit transmission will be done. For transmitting serially or for transmitting parallelly, we require the flip-flops. Okay, we require the flip-flops. Okay, so these are the functions that a digital circuit can perform. Okay, so apart from this, these are the functions of digital circuit. Is it clear for all of you? Okay. So next thing is quickly we will go into IC era. So levels of integration of an IC. Do you remember levels of integration of an IC? Yes. What are the different levels of integration? SSI, LSI, MSI, తర్వాత SSI, sorry, SSI, MSI, LSI, VLSI, ULSI. Okay, SSI means on a single IC, how many transistors we could accommodate? So tens of number of transistors. MSI means if you are able to accommodate 10 to okay 10 to 100. MSI is, yeah, medium scale integration. LSI means large scale integration. Okay, so some up till 10,000. Okay, up till 10,000 ICs, if you could able to integrate on the chip, then it is LSI. VLSI is greater than 10,000. Okay, so millions of transistors are being integrated today. Okay, so that ULSI technology కూడా క్రాస్ చేసేసాం. వై బికాస్ ఎస్ఓసిలో ఏంటిది అని అంటే, సో ఒక సింగిల్ కంప్యూటర్ మొత్తం ఒక చిప్ పైన డిజైన్ చేస్తున్నాం. ఓకే, దాంట్లో ఏముంటుంది, డిఎస్పి ప్రాసెసర్ విల్ బి దేర్, మైక్రో ప్రాసెసర్ విల్ బి దేర్, అనలాగ్ డివైజెస్ విల్ బి దేర్, డిజిటల్ డివైజెస్ విల్ బి దేర్. దట్ ఈస్ నథింగ్ బట్ సిస్టమ్ ఆన్ చిప్. ఒక చిప్ పైన కంప్లీట్ సిస్టమ్ యూఆర్ ఏబుల్ టు డిజైన్. ULSI మీన్స్ మిలియన్స్. Okay, millions of transistors on a single chip. So if you take after before 10-15 years back, so the diameter, the diameter, if you take one transistor, the diameter of the transistor is 30 times less than the diameter of the human hair, one small hair diameter to చూస్తే 30 times it was lesser. So these are the levels of integration, and also we have seen the functions of the digital circuits, and quickly we will move into one important PPT. We'll go with our syllabus. You can see, right, we will go with this flow. Binary numbers, binary arithmetic, number based conversions, octal and hexadecimal, binary logic, registers, codes, signed binary numbers, and complements. So see here, digital circuits. The digital computers are general purpose and scientific, industrial, commercial applications. These are the applications: telephone switching exchangers, digital cameras, electronic calculators, PDS. We have seen, right? And digital signal means greater accuracy will be there. An analog signal, so it may vary continuously over a specified amount of time. Okay, this is, and see, binary digital signal. It is having only two levels. Okay, so binary digital signal, so it is an information variable represented by physical quantity. So this, for digital systems, any variable it takes discrete, takes on discrete values. Okay, so two level or binary values. Two levels ante high low, binary values ante 0 1. So binary values are represented by digits 0 and 1, words. Okay, false and true, and low and high, and on, off. Okay, so you can represent this binary values like any way. Okay. So next one is, next slide, if we see. So logic 1 and logic 0, and in between the logic is, it is an undefined logic. Okay, logic 1 ki 0 ki madhyalo మనము ఏదైనా వచ్చింది అనుకోండి వాల్యూ, we can consider it as undefined one. Okay, undefined one. Okay, we can see binary numbers. So binary numbers చూడండి. So in this binary, let's start with binary numbers. We have binary, binary, octal, hexadecimal, decimal. All these numbers are there. So decimal number system lo we will be representing. Okay, normal. This is 51274 decimal representation. So base is also called as radix. Okay, for decimal number system, the base is 10. Okay, 10 digits. So 10 digits 0 to 9. 10 digits means starting one is 0 and ending is 9. Okay, we will be representing from 0 to 9. So this digit position is digit position, it may be in an integer and fraction. Okay, digit position is integer and fraction. Okay, so digit weight is nothing. Weight can be given as base power position. Okay, base position may be -2, -1, 0, 1, 2. These are all the positions. Base means what? 10. Okay, so base power position, it will give you the weight of the digit. So magnitude is nothing but it is a sum of digit into weight. Okay, let us see clearly again. So the 51274, it is the number. Okay, it is the decimal number. Okay, so what is the base? Base is nothing but this 10 is the base. 10 is the base. So digit position, these are -2, -1, 0, 1, 2 is representing the digit position. Okay, it is representing the digit position. Okay, next digit weight is nothing but digit weight is nothing but base power position. So 10 power 2 is 100, 10 power 1 is 10, 10 power 0 is 1, 10 power minus 1 is 0.1, 10 power minus 2 is 0.01. Okay. So now what we are doing is digit into weight we are doing. Digit into weight is giving the magnitude. This is 5 is the digit into this is weight. 100 is the weight. Okay. 100 is the weight. Okay. So this is digit into weight. So digit into weight, 5 into 100 is equal to 500. This is called as magnitude. And 10 into what? 1 into 10 is nothing but 10. 1 into 2 is 2. Okay. So 0.1 into 7 is nothing but 0.7. 0.01 into 4 is nothing but 0.04. Okay. So finally, if you want to get the complete magnitude, so finally, if you want to get the complete magnitude, what you need to do? You need to sum up. Okay. If you are summing up, it will be 500 plus 10 plus 2 is 512. 0.7 plus 0.04 is nothing but 74. So base 512, 0.74 base 10. Okay. So once again, I repeat. So this is nothing but your digit. Okay, this is nothing but the digit. So what is 10 is nothing but your base. Okay, it is also called as radix. So 10 power 2 is representing the digit position. Okay, digit position, integer and fraction. So 5 into 100, it is giving digit into weight. Okay, this is digit into weight. Then mundu weight and rasana. So sorry, digit into weight. And this is digit into weight. Completely, if you are summing up together, it gives you the total magnitude of this. Okay. The total magnitude. This is the decimal number system. So I hope you know these things. Even is simple. So if you see the octal number system ante octa ante 8. For octal number system, base is 8. So totally 8 digits we will be taking 0 to 7. Okay. So weight always it will be base power position. Magnitude is sum of digit into weight. So same number if we are taking octal 2, 1, 0, minus 1, minus 2 are representing the position. Okay. So we will start from here 4 ante minus 2 and ikkada 512.74 minus 2 minus 1 0 1 and 2. So 8 square is 64. Okay, 8 power 1 is 8 0, 8 power minus 1 is 1 by 8, 8 power minus 2 is 1 by 64. So this number into what you are doing, weight. Okay, number into weight. This is the number into this is the weight. So you have to multiply 5 into 64, 1 into 8, okay, 2 into 1, 7 into 1 by 8, 4 into 1 by 64, which is giving you 320 plus 8 plus 2, 0.875, 0.0625. Okay. So if you are summing up together, what you are getting 512.74 base 8. Okay. So this is the representation of the octal number system. Okay, representation of octal number system. Okay, next one is hexadecimal number system. Hexadecimal number system, base will be 16 for the hexadecimal number system. 16 and ante till 9 we are taking. 9 tarvata 10, 11 తీసుకోకుండా A, B, C, D, E, F. Okay. So 16 ante 0 to 15 we are taking. So from 10 we are representing with alphabets. Okay. So A is representing 10, B is representing 11, 12, 13, 14, F is representing 15. Okay. So weight is obviously base, power, position, magnitude, sum of bit into weight. Okay. So 1 is represented with, so here also 1E5 7A. Okay, 1E5 7A. Okay, A is 16. This is there. So A is 16 power minus 2, 7, 16 power minus 1. All these are the base. Okay, so base into position values. These are all. Okay. So next one is 16 square is equal to 256. 1, 16 power 0, 16, 1, 16 power minus 1, 1 by 16, 16 power minus 2 is 1 by 256. So 256, and here E is nothing but E is representing 14. 14 into 16 is 224. 5 into 1 is 5. Okay. 7 into 1 by 16 is 0.4375. This A is representing what? 10. Okay. So 10 into 1 by 256 is 0.039. If you are summing all these things together, what you are getting? 1E5.7A. So this is the hexadecimal representation. Okay, hexadecimal representation. Let us suppose making the ఈ 1E5 7A ne. So if I ask you to represent in octa, what you will do? Octa lo represent చేయమంటే ఇక్కడ ఏం చేస్తారు చెప్పండి. ఇక్కడ 16 power 2 దగ్గర ఏమొస్తుంది? చేయొచ్చా? 16 power దగ్గర 2 దగ్గర 8 power 2. సరే, ఈ అనేది ఉంటుందా ఆక్టాలో? ఈ అనేది ఉంటుందా ఆక్టాలో? మరి కన్వర్ట్ చేయమంటే కన్వర్ట్ చేసేస్తామని ఈజీగా చెప్పలేదు మీరు. బట్ సి యూ హ్యావ్ టు చెక్. ఓకే. సో వెదర్ హెక్సా, ఇప్పుడు దీన్ని మీరు వాట్ హెక్సాడెసిమల్ నంబర్ ని యూ కెన్ కన్వర్ట్. ఓకే, యూ కెన్ కన్వర్ట్ ఇంటూ వాట్ బైనరీ కన్వర్ట్ చేయొచ్చు, డెసిమల్ కి కన్వర్ట్ చేయొచ్చు. బట్ వాట్ యూ హ్యావ్ టు సీ వెదర్. నెక్స్ట్ one is binary numbers. Binary numbers ante 10101. Okay, base 2 binary ki base 2. Okay, base 2. So binary lo 0 and 1 రెండే ఉంటాయి. Okay.
హెక్సాడెసిమల్ లో మనం ABCD రిప్రజెంట్ చేస్తాం కదా మన ABCDEF అప్ టు F వరకు. అది క్యాపిటల్ రిప్రజెంటేషన్ మన స్మాల్ రిప్రజెంటేషన్. ఐ మీన్ ఏంటంటే కొన్ని వీటిలో స్మాల్ అని చెప్తున్నారు, కొన్ని దగ్గర
పక్కా క్యాపిటల్. మీరు స్మాల్ ఎక్కడ యూజ్ చేయొచ్చు. ఓకే, డోంట్ గెట్ కన్ఫ్యూజ్డ్. ఓకే,
ఓకే మేడం.
ఎందుకంటే స్మాల్ అంటే మళ్ళీ దానికి వేరే వాల్యూ ఉంటది. స్మాల్ లెటర్స్ అంటే వేరే వాల్యూస్ వేరే వెళ్ళిపోతాయి. అవి చూపిస్తాను మీకు, నేను షేర్ చేస్తాను వీడియో.
ఓకే మేడం. ఓకే మేడం.
సో ఒకవేళ ఇప్పుడు ఇది ఇచ్చి మీకు కన్వర్ట్ చేయి 1E5 7A ని ఆక్టాగా కన్వర్ట్ చేయమన్నారు అనుకోండి. సో మీరు ఫస్ట్ దాన్ని ఏం తీసుకుంటారంటే బైనరీ కన్వర్ట్ చేసి తర్వాత ఆక్టా కన్వర్ట్ చేయాలి. అర్థమైందా? సో 1E5 7A డైరెక్ట్ గా మీరు ఆక్టా కన్వర్ట్ చేయలేదు. కన్వర్షన్స్ వీ విల్ టేక్ కేర్, డోంట్ వరీ. సో సి హియర్ బైనరీ కదా మనం డిస్కస్ చేసేది. బైనరీలో చూడండి. సో బేస్ టు ఓన్లీ 0 and 1, 2 digits. ఓకే, అందుకని బై అంటారు. 2 digits 2 values కాబట్టి బైనరీ. ఓకే, నెక్స్ట్ థింగ్ ఇస్, సో వెయిట్స్ ఏంటి చెప్పండి. 1 is equal to ది సి ఇక్కడ 2 power 2, 2 power 1, 2 power 0. ఇక్కడ పాయింట్ ఉంటుంది చూడండి. 2 power పాయింట్ లేకుంటే ఫ్రమ్ హియర్ యూ షుడ్, పాయింట్ లేదనుకోండి ఇక్కడ నుండి 2 power 0 నుండి స్టార్ట్ చేస్తారు. ఓకే, ఇక్కడ పాయింట్ ఉంది, దట్ ఈస్ నాట్ రిప్రజెంటెడ్ హియర్. ఇక్కడ 101.01 ఉంది. 0 2 power minus 1, 1 2 power minus 2. Okay, 2 square is equal to 4, 2 power 1 is equal to 2, all these things. Okay, so next 4, what is this? 0 into 2, 1 into 1, 0 into 0 into 0.5. Okay, 1 into 0.25, 1 into 1, 0 into 2, 1 into 4. Okay, if you are adding these things, what you will get? 1, 0, 1.01. Okay, so in binary, so మీరు binary కాకుండా మీరు యాడ్ what base 10 అయితే 5.25. ఓకే, base 10 అయితే 5.25. అదే binary అయితే so it will be 101.01. okay, so 4 plus 0 plus 1 is nothing but 5. okay, 0 plus 0.25 is 225. okay, 5 అంటే ఏంటిది binary representation 101. 0.25 అంటే it is 0. okay, so this is about binary. Now we will see the next slide. So ఇక్కడ చూడండి, power of 2 లో n is equal to 0 అయితే 2 power 0 is equal to 1. 2 power 1 2, 2 square 4, 2 cube. సరే, ఇక్కడ వరకు మనకు తెలుసు 2 power 10, 2 power 11, 2 power 12. 2 power 20 is nothing but 1 mega. 2 power 30 is 1 giga. 2 power 40 is 1 tera. ఓకే, సో ఇవి గుర్తుపెట్టుకోండి మీరు ఇక్కడ వరకు అని అంటే, సో ఈజీలీ వీ కెన్ గెట్. ఓకే, దిస్ ఇస్ అబౌట్ బైనరీ నంబర్స్. నెక్స్ట్ థింగ్ ఏంటిదంటే, సో బైనరీ అరిథమెటిక్. దీంట్లో మనం అడిషన్ చూస్తాము. దిస్ ఇస్ డెసిమల్ అడిషన్. డెసిమల్ అడిషన్ అంటే చూడండి, 5 5 5 5 55 55 యాడ్ చేస్తే 110 వస్తుంది. ఓకే, సో డెసిమల్ అడిషన్ సింపుల్ థింగ్. ఇప్పుడు బైనరీ అడిషన్ చూడండి. బైనరీ అడిషన్ లో సో ఇది పక్కన పెట్టండి. ఇఫ్ యూ సీ దిస్ నంబర్, ద ఈక్వాలెంట్ ఇస్ 61. 61 ఈక్వాలెంట్ ఏంటిది అని అంటే, దిస్ ఇస్ వాట్ ఈస్ దిస్ 2 power 0, 2 power 1, 2 power 2, 2 power 4, ఓకే, 2 power 3, 2 power 16 రాసేద్దాం డైరెక్ట్ గా. సో ఈక్వాలెంట్ ఏంటిది? వాట్ ఈస్ దిస్? 1 2 4 8 16 32. ఓకే, 31s ఎక్కడెక్కడ ఉన్నాయి? 32 ప్లస్ 16 ప్లస్ ఈక్వాలెంట్ ఏంటి చెప్పండి? సో ఇది 32 ఇక్కడ రాస్తున్నాను చూడండి. 32 ప్లస్ 16 ప్లస్ 8 ప్లస్ 4 ప్లస్ 2 లేదు కదా చూడండి. ఓకే, సో 32 ప్లస్ 16 ప్లస్ 8 ప్లస్ 4, ఇక 2 దగ్గర 0 ఉంది కదా, పొజిషన్ 2 దగ్గర, ప్లస్ 1. ఓకే, 32 plus 16 will be equal to 48. 48 plus 8 will be equal to 56. 56 plus 4 will be equal to 6. 60 plus 1 is equal to equivalent to 61. అలానే చూడండి, ఇది ఏంటిది? 16 plus 4 20, 20 plus 2 22, 22 plus 1 23. 1 1 is 0. Okay, so 1 1 is 0. 1 is your carry. Addition మీకు తెలుసు, బట్ స్టిల్ ఒక 1 minute చెప్తాను. 1 1 is 0. 0 అయితే 1 will be the carry. 1 and 1 0. 1 will be the carry. 1 1 1 అంటే ఏంటిది? 1 1 0. ఓకే, సో 1 1 0 and 0 1 1 and 1 will be the carry. 1 and 1 0. 1 will be the carry. ఓకే, సో 1 1 1 అంటే sum 1 carry 1. 1 1 sum 0 carry 1. ఈ క్యారీ ఇక్కడికి వస్తుంది. దిస్ ఇస్ డెసిమల్ అడిషన్. ఓకే, సో అదే విధంగా సో డెసిమల్ సబ్స్ట్రాక్షన్. సబ్స్ట్రాక్షన్ ఎలా చేస్తారు? ఇక్కడ మీరు ఎక్కడ కన్ఫ్యూజ్ అవ్వకండి సబ్స్ట్రాక్షన్ లో. సో ద ఈక్వలెంట్ ఆఫ్ దిస్ వన్ ఇస్, మనం ఇది ఓకే, ఇది ఏ అనుకోండి, ఇది బి అనుకోండి, మనం ఏ మైనస్ బి చేస్తున్నాం. దిస్ ఇస్ నథింగ్ బట్ ఏ మైనస్ బి. సో 1 minus 1 is 0. ఓకే, 0 minus 1 చేయలేం, అందుకని ఏం చేస్తున్నామంటే ఇక్కడ 1 ఉంది కదా, ఇది ఇక్కడికి తీసుకొచ్చుకోండి. ఓకే, సో 1 0 ఈక్వలెంట్ ఇస్ నథింగ్ బట్ 2. ఓకే, 1 0 మీరు రిప్రజెంట్ చేస్తున్నారు కదా బైనరీలో. ఓకే, దిస్ విల్ బి, సో వాట్ ఈస్ దిస్? దిస్ ఇస్ బైనరీ ఈక్వలెంట్ విల్ బి 2. ఓకే, సో ఈ 1 ఇక్కడ తీసుకొచ్చుకుంటే ఏముంటుంది? ఇట్ విల్ బి 1 0. బైనరీ ఈక్వలెంట్ ఇస్ 2. 2 minus 1 is equal to 1. ఓకే, సో ఎక్కడైనా కన్ఫ్యూజ్ అవుతున్నారా? Here you cannot, ఇక్కడ నుండి you have taken this 1 here, ఈ పక్కన పెట్టారు. ఈ 1 0 is nothing but it is representing 2. Okay, so దీనిలో నుండి 1 తీస్తే we will get so 2 minus 1 is equal to 1. And here again you need to take, ఇక్కడ నుండి మళ్ళీ ఇక్కడ 0 ఉంది కదా, so again you need to take this borrow. So this is equivalent to కదా, 2 minus 1 will be equal to again 1. Okay, so అప్పుడు ఇక్కడ 0, ఇక్కడ ఇది క్యాన్సిల్ అయిపోయి ఇక్కడ 0 వస్తుంది కదా. Again what are you doing? You are taking, here it is 0 but still you are taking borrow 1, and 1 0 equivalent is 2. Okay, is it clear or you are getting any doubts?
No madam, subtract చేయడానికి అక్కడ 0 ఉంది కదా, so no issue.
Subtraction you can do, there is no, yes. Okay,
Yes.
right. So మీరు సబ్స్ట్రాక్ట్ చేయలేని దగ్గర పక్క నుండి ఏం చేస్తున్నారు, యు ఆర్ టేకింగ్, సో ఇక్కడ ఏంటిది అని అంటే యు ఆర్ టేకింగ్ ద బారో. ఇన్ ద సేమ్ వే ఇఫ్ యూ టేక్ హియర్, సో ఇక్కడ నుండి యూ హ్యావ్ టేకెన్ దిస్. ఓకే, ఇక్కడ 0 ఉంది కదా, ఇక్కడ నుండి మీరు ఏం తీసుకున్నారు అని అంటే 1 0 ఈక్వలెంట్ ఇస్ నథింగ్ బట్ 2. 2 minus 1 will be equal to 1. ఓకే, సో ఇక్కడ తెచ్చేసుకున్న తర్వాత వాట్ ఎవర్ ది ఫైనల్ 1 is there, you are shifting here. 1 minus 0 will be equal to 1. This is the subtracted, this is the what is the difference. Okay, so subtraction. Tarvata next multiplication అనేది మీకు చెప్పాల్సిన పని లేదు. బైనరీ మల్టిప్లికేషన్ బిట్ బై బిట్. 1011 1011 ఈక్వలెంట్ ఏంటి చెప్పండి ఫాస్ట్గా. 10111. సో ఏంటిది ఇక్కడ 1 2 4 8 16 నేను రాశాను. ఈక్వలెంట్ చెప్పండి.
23
20 33 23 23. ఓకే, సో 1010
10
23 into 10 is equal to 230. Right. Okay, so here 0 into anything will be equal to 0. This is the first what product term. Next 1 into this will be equal to the second product term. 0 into this will be 0. 1 into this will be 1. Okay, ఇలా మీకు ఏమంటారు, పార్షియల్ ప్రొడక్ట్స్ అంటారు. వీటిని ఏమంటారు అంటే దీస్ ఆర్ కాల్డ్ as PPs, పార్షియల్ ప్రొడక్ట్స్. పార్షియల్ ప్రొడక్ట్స్ వచ్చేసాయి, ఏం చేస్తున్నారు మీరు, సమ్మింగ్ అప్. ఓకే, so 0 1 is 1, 1 is 1, 1 1 0, and here you will get 1 carry, 1 1 0. Okay, 3 ఉన్నాయి కదా, sum 1, and here also carry 1 ఇక్కడ వచ్చింది. ఓకే, నెక్స్ట్ 1. సో దీన్ని ఏంటి చెప్పండి, వాట్ ఈస్ ద ఈక్వలెంట్? ఇది 230 కాదా? 1 2 4 8 16 32 64. వాట్ ఈస్ దిస్? 128. ఇప్పుడు 128 plus 64 plus 32 plus 4 plus 2 ఎంత? 230 వచ్చిందా లేదా? Very good. This is 230. This is 230. Okay, so this is binary multiplication. So binary multiplication tarvata next what we will see is number based conversion. Okay, number based conversion. ఇప్పుడు ఏంటంటే number based conversion లో so decimal అంటే base 10, decimal base 10, whatever the integer number is there. So with decimal base 10 number we can convert to octal. Okay, we can convert to binary, and we can also convert to hexadecimal. ఈ hexadecimal ని మళ్ళీ we can convert to decimal. Okay, we can evaluate the magnitude. Binary ని కూడా మనం decimal కి కన్వర్ట్ చేసి we can evaluate the magnitude. అంటే ఏంటిదంటే a final value. Okay, octal ని కూడా మనం decimal కి కన్వర్ట్ చేయొచ్చు. We can evaluate the magnitude. Okay, so we will see all these things. So now if you see number based conversion లో anything you can divide the number by the base. Okay, which is equal to 2. The first thing is we are seeing the decimal to binary conversion. Okay, decimal to binary conversion ante binary anante you should divide by base 2. Okay, divide by base 2. Okay, so next take the remainder either 0 or 1 as a quotient. Take the quotient and repeat the division. We will see that. Okay, theory antendukane. So we will see that number base conversion lo. Okay. So see here, decimal integer value ante enti manaki 13 ichchadu kada. So 13 binary, but binary conversion ante we have to take 2. Okay. So what 13 2 into 6 12. What is the remainder? 1. Quotient remainder is 1. Are you there with me?
Yes, ma'am.
Okay. So what is this? 13. Okay. So 2 6 12 kada. What is the remainder here? 3 is a 6. Okay. So here it is 0 and 2 is a 2 1. Okay. 1 1 1 0 1. Okay. So what are the quotients you are getting? 1 1 0 and 1. Okay. So 1 1 0 a not 1 1 0 1 kada. We have to start from like ఇది a not a not a not ఇది a1 ఇది a2 ఇది a3. Okay, so similar a0 a1 a2 and a3. So 1 1, what is the binary equivalent for the 13? It is nothing but 1 1 0 1 base 2. Okay, so next one is decimal to binary conversion. ఇప్పుడు ఒక decimal number ఉంది. Okay, so 0.625 అనేది decimal. Okay, to ఇది ఏంటిది ముందు తీసుకుంది ఏమంటే జస్ట్ ఇంటిజర్ వాల్యూ, ఇది ఫ్రాక్షన్. ఓకే, దిస్ ఇస్ ద ఫ్రాక్షన్. ఫ్రాక్షన్ కన్వర్ట్ చేయాలి అని అంటే వాట్ యూ నీడ్ టు డూ 0.0625. ఓకే, బేస్ 10 కదా డెసిమల్ అంటే, సో ఇంటూ 2. ఓకే, సో ఈ పాయింట్ కి ఇటు సైడ్ ఆర్హెచ్ఎస్ సైడ్ ఉంటే ఇంటూ 2. ఓకే, సో ఇంటూ 2 చేస్తే యూ విల్ గెట్ 0.65 ఇంటూ 2 యూ విల్ గెట్ 0.625 into 2 is equal to 1.25 వస్తుంది. సో దిస్ ఈస్ 1.25 1 ఇంటీజర్, తర్వాత ఫ్రాక్షన్ వచ్చి 25. ఓకే, సో వాట్ ఎవర్ యు ఆర్ గెటింగ్ ఇఫ్ దిస్ 25 you take, okay, and again you multiply into 2, what you are getting 0.5. okay, 0.5 lo 0 is the integer and 5 is the fraction. 0. Again 5 you are 0.5 you are taking. Okay, 0.5 you are taking 0.5, what you are getting 0.5 into 2 which is equal to 1. Okay, 1.0. 1 is the integer and 0 is the fraction. Okay, so what is the quotient that you are getting? 1 0 and 1. ఇక్కడ ఉంది చూడండి ఇంటీజర్ వాల్యూస్ నే 1 0 and 1. So what you are doing 0, ఇది fraction కాబట్టి 0 1 0.101 base 2. This is nothing but fraction. Okay, decimal fraction to binary conversion. If it is a fraction, you can convert into binary in that way. Okay, so now decimal to octal conversion. Okay, so decimal to octal conversion అంటే decimal అంటే integer value, octal అంటే base ఏంటిది octal కి? What is the base? 8. Okay, so base 8 ante 175. Okay, so 8, what you are getting here? 8 2 is 16. Okay, 15 ante 8 1s. What is the remainder that you are getting? 7. Okay, similarly 8. Okay, again, so 8 2 is 16. What is the remainder? It is 5. Okay, so what you are getting? 7 5 and 2. This is a0. Okay, this is a1 and this is a2. So 7 5 2 we are getting. Quotient is 7 5 and 2. Whatever the remainder, that is 7 5 and 2. Okay, so answer is equal to, so answer you have to write from MSB to LSB. Okay, so A2 mundu A1 tarvata A0 last. So 2, 5, 7 ఇలా రాయాలి 2, 5, 7. ఓకే, తెలుసు కదా, ఇది MSB అంటారు. మోస్ట్ సిగ్నిఫికెంట్ బిట్ is the least significant. Okay, so MSB to LSB you have to write. Okay, next decimal to octal conversion. Okay, decimal to octal conversion అంటే, సో డెసిమల్ అంటే వాల్యూ అదే ఫ్రాక్షన్ తీసుకున్నాం. అదే ఇంతకు ముందు ఏంటిది అని అంటే నంబర్ ఇంటీజర్ వాల్యూ తీసుకున్నాం. ఫ్రాక్షన్ అంటే మళ్ళీ అగైన్ 0.3125 ఇంటూ 8. అయితే వాట్ we are getting 0.3125 ఇంటూ 8 is equal to 2.5. 2 అనేది ఏంటిదంటే ఇంటీజర్, 5 అనేది ఫ్రాక్షన్. ఓకే, ఇంటీజర్ అండ్ ఫ్రాక్షన్. సో అగైన్ వాట్ దిస్ ఇక్కడ ఉంది కదా 0.5, ఈ 0.5 ని తీసుకొని అగైన్ యూ మల్టిప్లై విత్ 8, యూ ఆర్ గెటింగ్ 4.0. ఓకే, 4.0. Okay, so 4 is the integer and 0 is the fraction. So what you are getting, the integer values 2 and 4, 4 treated as quotients. Okay, so this is MSB and this is sorry ikkada entidi anante, so you have to write in this form. Idi emante fraction kabatti 2 and 4 you have to write. Okay, 2 and 4 you need to write. Ade itu side aithe you have to come from MSB to LSB. So next one is octal and hexadecimal numbers. This we will discuss tomorrow. So I will give you some assignment. Will you do it? Will you do it?
Yes, ma'am.
Yes. Assignment cheyandi. See, small things. Okay, in coming days I'll give you. I will increase the load on you, but now small things. We will start from scratch. Small things. So, and see one more